All right. So last time we concluded, we looked at this script on how to analyze acceleration data. And we came up with this plot for a characteristic signal of the phone while I was walking and the phone's in my hand, right? And we need to learn how to save all of this information into one variable where, if I had a bunch of different plots like this, I could plot them all at once, right? So we first need to look at this type of variable called a cell, right? And if we make a bunch of, say, vectors, 1, 2, 3, 4 is A, say B is equal to 1, 2, C is maybe some string or something, my data, right? Say we had all this data that we want to save, and we want to locate that into one variable that we can work with later, right? And we want to do some more analysis and finally accumulate a bunch of data into one variable and then use that variable to plot. Right? What we need to do is look at what's called a cell, and cell, instead of using these brackets that look like this, right, to make a vector, this is just open and closed bracket. We use open and close curly bracket, which is just shift on bracket, right? You can see the difference between this and these. These are the straight open brackets, and these are the curly brackets. So cells use what's called curly brackets. And the special thing about cells is we can put a bunch of different vectors in them. Okay. So D is a collection of vectors. And those vectors all have different length, right? So A, remember A was 1, 2, 3, 4, and that's in cell 1, 1. In cell 1, 2, we have B, the vector B is 1, 2. And we have the string my data, and that's saved in cell 1, 3. Okay? And we did that using these curly braces. So if we want to pull out one of these vectors, we have to, instead of, remember, if we wanted to pull out the first component of A, we would use A of 1, right? For D, if we did that, let's see what happens. D of 1. Well, MATLAB returns a cell version, okay, of whatever's in the first cell. So the answer ended up being a cell array of one single thing, and we don't want that. Okay? Instead, what we want is to pull out that vector, and to do that, we use the curly brackets. So D curly brackets of 1, and we pull out the vector we want. So this is going to, this idea of how we typically take things out is these just curly brackets, A of 1, right? Versus D of 1. D of 1 returns a cell, and then D of curly 1 returns the array that we wanted. Keep that in mind. That's going to probably trick you up a bunch of times. Okay. So how do we use that to our advantage when we go and try to save our data, right? Well, instead of plotting the data, we hadn't just save TM and AM. What we can do is write these cells that we're going to make. We can write T tm curly bracket of I is equal to tm. We can write a curly bracket of I is equal to a maybe we should probably rewrite these things as like cell or something, so that we remember, you know, hey, this is what's going on. Okay. So if we do this, we run that, you can see that our data over here, tm cell, is now a collection of 1 by 43 cells. Okay, so open that thing up. And you can see now we have a bunch of these data arrays, and they're all stacked on each other. You see that? So now if I wanted to save that array of data, right, I wanted to use it later somewhere else, I can just write in save. I write in save. I can say a title of the file that I want to make. So I can say this is AJM walking hand .mat, right? And then it asks for, okay, so if I just hit run right now, it's going to save all that data here as AJM walking hand.mat. And you'll see all these variables pop in. And all those variables are everything that we have in our window on our workspace right now, right? All those things got saved into a little structure, a little file, right? But say we just cared about saving TM and AM, right? We didn't want all this extra data. I mean, all that extra data is not so bad, right? But if we just wanted TM and AM, we can just write those here. Just write them as these strings following our save file command, right? The first thing we got to input is our save file. And then we input all the things that we want to save from our little workspace over here. Okay. So I'm just going to delete this guy. Delete it. And I'm going to rerun this. And I don't want that figure popping up every time, so I'm just going to do that. Okay. So now that we've specified only the variables that we really want to save, all right, we click on this guy and the variable workspace is here. Right? So what this allows us to do, what if I, in my command window or my script or something, what if I said, let's clear the workspace. So the workspace has no variables in it right now. But if we loaded our data set, you can see that my analysis, the stuff that I saved from my analysis comes back in to my workspace. It's pretty cool, right? So if we want to use this idea, remember that if we have the same variable name, if we have the same variable name, let's say we save this whole thing again. Let's do this like, oh, we did another version 2 or something like that, right? Well, if I save that, if I run all this, whoop. Something happened. What did I do? Oh, look at this. my data in here is called the same thing. So that was a bad choice, huh? Okay. Whoops. That's a good learning lesson. You gotta name this stuff something like data. I'm gonna name that analyzed. So now we can delete it. And if we run that again, okay. Now our data saves like what we want, right? And then we'll name this like version 2. Let's run that again. Okay. And now I want you to see this. Clear CLC. Our workspace is clear. And we open up our data set, our workspace, right? And say then we wanted to open up our next set of data. And there's no change, right? And the reason why is because it's overwriting the variables with the same name. So how do we get a bunch of data together if we're going to name them all the same name all the time, right? What we're going to have to do is write this for loop later in our next analysis, right? After we've done all our analysis of saving these data and stuff like that, we want to do let's just make another script. We're going to write this one. We're going to call it like plot. All right, so the first thing we want to do then is load what? What the data that we care about, right? This one. Okay, so in our plot function, right, we load the data we're saving over here. Okay. Now this doesn't actually make any sense. What we got to do is we got to write a cell array of the data. Okay, so remember, the cell array has these curly brackets, right? And we can write a bunch of different stuff in here. So we can write in actually, you know what I'm going to do? I'm going to make a whole new data set real quick. Let's go back to Excel data. I'm going to call this one, let's analyze my jogging hand. Okay, so all I did was I saved. I'm going to write my save variable differently. In this case, it's jogging hand analyzed. And then the data I'm trying to load for that is going to be the jogging hand, right? AJM jogging hand.mat. Okay, cool. So now we have to do this whole thing again where we find the right peaks. Find the MPD that gives us the right peaks, right? So we'll run these sections. Yeah, we better keep this stuff in mind, right? We have to make these sections come later so that we can do we're gonna have to do a whole different plot or a whole different script just to find MPD first. So here we can just we can say we're cropping that data here. This is going to be T versus A mag. All right, so run that, run that, run that. This should pop up a figure with all my peaks. And so MPD is definitely too big. We gotta take it down. Let's rerun that section. That looks pretty good. I like those peaks. Not missing any peaks. I think that's a good. That's gonna work out. All right, so this one, where do we crop it from? Well, let's start the crop right here at 157 and end here or here. Actually, I like all this data in between 200 and this one. So let's actually crop it from this one, 202 to 1021. So let's do that. So crop start, put it here. Crop end, put it there. Cool. Making this code better every day. All right, MPD's gotta stay with the one we're doing up here, right? And everything else is probably going to work out pretty good. We got nothing I can see. It's going to kick us an error here. So, right? Let's just run it. And actually, let's get a plot out of this thing too. We gotta say plot. We're gonna do TM versus AM. And hold on, right? Okay. So let's just run this thing. Well, that's pretty cool. Looks kind of like the walking in the hand, except I don't have that weird peak in the middle. Like that one got flattened out. And it looks like also the TM, right? The TM is essentially looking at how quickly I'm making steps. And that looks like it's shortened. Remember, the walking was a TM of 0 to 1.2, and now it's a 0 to 0.4-ish, something like that. Okay. That's pretty cool. What's cooler is now I have two sets of data that we can kind of come in and plot with. So my plot data, I'm going to call the first thing walking hand. The second thing is going to be jogging hand. analyzed, right? All that stuff should be correct. All right. So then we need to kick a for loop off for I equals 1 to, well, you know, we need to know the number of the number of things that we put into data names, right? How many different sets of data do I have in data names? And we can use this function called numl. Numl gives us the number of elements. So we use for I equals 1 to numl data names. And then we want to load data names of I. All right. So I, the first time it goes through, it says I equals 1 right here. And in this case, there's two things of data in data names, right? There's my first set of data I collected and second set of data I collected. We put that to numl data names and we spit out the number 2. So I goes from 1 to 2. And we load data names, curly brace of I. Curly brace of I. And that's going to take out the first thing in data names, right? Because I equals 1. So the first thing in data names is going to come out and we get a load. So that's going to load AJM walking hand analyzed. All right. So now what's convenient about having, so let's clear this. Let's always make sure we clear the data set. Clear, comma, CLC, semicolon. Okay. So right here, we are, we're going to put in, make a cell array of all data file names. Okay. Now we run through each data file and do something. Here we're going to load the data. Okay, so let's say we wanted to plot both of these things with each other. So let's say now I need to plot plot the stuff in each data set. Okay. So let's see what happens if we open this one up. Remember these variables, AJM jogging hand. The output was AM cell and TM cell. And then this one, it was the same output, right? We named the variables the same. We were very consistent when we did that. Well, when we're in here, we can utilize that consistency by just saying plot the stuff in each data set. Okay, well, I can just go what's in AM cell. I know this is a bunch of different, just a bunch of different arrays, right? Or just a bunch of different strings of data. And I know that AM cell 1 corresponds to TM cell 1. I know that, right? So when I'm doing my analysis, I can just say, let's say, pull AM back out. AM equals AM cell curly open brackets, right, of, oh wait, man, I need to go run through all of these cells and do something, don't I? Okay, well, we can do that, no problem. We just write this for loop thing again. For, can't do I, we can do like j or something this time. J equals 1 to numL am cell, right? Because, hey, we got that. We got that now because we loaded it here. So we have access to that variable. Right, so now that we have that, we can run through all of these different cells and plot, and then now that variable am is equal to whatever's in that cell. Let's do the same thing for the t. The tm is now tm cell. TM cell j. Okay. So in here then we could plot TM versus AM, right? So let's see what happens when we do this. All right, I think this all just should work. Oh, we didn't hold, so we got to hold on. And let's just make a new figure. All right, so we got two things going on here, right? The jogging version is now like kind of condensed because we're using this as like a seconds per step, right, for analysis. And this one is going to be some type of acceleration. So we can see that jogging gives us more acceleration magnitude than walking. And walking gives us a different rate of stepping, like how many seconds per step, right? Which is, I mean, pretty obvious. You would be able to guess that. Okay. So say we wanted to just compare the signal though, right? We wanted to compare what these signals look like. Well, we would need to do what's called a normalization. And to do that, we can go AM normal is equal to AM divided by the max of AM. So if we do that, then we know the magnitude of acceleration, the maximum that we're going to get in each one of these things is going to be 1. So it's going to be a number, AM norm is going to be a number from 0 to 1 for all these cases. So let's do TM. TM norm. TM norm is equal to TM divided by max TM. And then we could just plot these together. All right, there we go. Okay, so we got another problem, don't we? It's like, how do you kind of distinguish between what's going on? Because all these plots are different colors. So we got to color these plots differently depending on which data set we're in and blah, 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 right? All these things. All right, so we can write this other cell called color. And we'll write a bunch of different colors here. Call this one like R. And how do you do colors and plots? you can just, right here, you write in like R, and that'll do a red plot every time, right? So well, we want to take advantage of that. You can just type in R for red, green, G for green, B for blue, C is cyan, we got magenta for M, we got K for black. All right. So let's say those are all the colors we wanted to run through. All we got to do is now, let's say, right, if we made this, if we went and made that right there, and we said color cell of one curly brackets, we return R. And check this out. We can take in color cell and put it at the end of our plot, just like we do if we type in R, just like that, right? So we can say of I, right? We can say every time you switch data sets, data names, load a different data set, also change the color of my plot to these color cells that we give here. Okay. So we run that. And now you can see that red is all the walking data and green is all the jogging data. Okay, that's pretty cool. All right, so let's see where we're at here.